We're going to spend the majority of our time talking about vision because vision is our dominant sense, all right? We as human beings, vision is number one. There's just no doubt about it. Roughly half of the sensory receptors in the human body located in the eyes, all right? An entire lobe of your cerebral cortex devoted to processing visual information. And remember, a lot of the temporal lobe has to do with that as well. Got the brainstem structures, the superior colliculus, and so on, the thalamic nuclei. You devote a lot of processing to vision. It clearly is what gives us most of our information about the world. Eyeball is about 1 inch in diameter. About 80% of your eyeball is enclosed in the orbit. So when you look into someone's eyes, and I know you love to do that, as disgusting as it is, you're only seeing about 20% of their eyeball. All right. Vision information carried by cranial nerve 2, we already know that. Optic nerve, strictly sensory. Oops, I talked over the transition. I'm not supposed to do that. Tears, yeah, good. They clean, protect the eye. Milliliter of tears produced every day. Spread over the eye by blinking, just like the windshield wipers, Spread, you press a little button, it sprays onto the window. And yeah, same thing with your eyelids and the tears. Tears contain antibodies, IgA, and a bactericidal enzyme, lysosome. So yeah, they help try to keep you from getting conjunctivitis. So the tunics, the layers, tunic, a shirt-like thing, kind of hung down below your waist. So that's like what the knights wore in medieval times and stuff. So it's often used to mean basically just a layer. So there are 3 basic layers of your eyeball, and I already talked about them in the anatomy PowerPoint, but let's look at them again. So the fibrous tunic is the outermost layer. That consists of the sclera and the cornea. Once again, it's all basically the same stuff. It's just the molecular arrangement. The molecules are arranged in the sclera so that they're opaque, and the cornea they're arranged to make it clear. The vascular tunic, the middle layer, consists of the choroid, ciliary body, iris, and lens. Vascular, again, means this has got the blood supply. And then the nervous tunic, the inner layer, that's the retina. That's where the actual detection of light takes place. That's where the photoreceptors are, okay? So those are the 3 basic layers. Each one has its own purpose. Fibrous protects the eye, all right, and also does some of the focusing, the cornea does. Vascular supplies the oxygen and the glucose that the rest of the tissue needs. And then the nervous actually detects the light. So the sclera, tough, tendon-like layer, protects physical protection. It's actually hard to poke through somebody's sclera. I'm not recommending you try. But it's crazy injuries, like in sports it happens a lot. My son is a MMA fighter, and sometimes he's mostly a grappler because his girlfriend doesn't like to see him get hit by other people. So he's a black belt, actually, by the way. He just got his black belt. It's something he didn't really try for a long time, then finally did, and he got it. And he's damn good. My son is undefeated for I don't know how many matches now in a row. But at any rate, that happens a lot. Somebody's trying to grab you, and their hand claws across your face and across your eyeball. He's gotten scratches on his sclera several times, but it's tough stuff. It's hard to poke through. Again, don't try. But cornea, clear structure. He's gotten a scratch on the cornea as well, and that was pain, he said, like you would never imagine. So, but that's it refracts and focuses light onto the retina. So cornea does most of your focusing for you. Choroid, rich blood vessels, nutrients to all the structures. Lens is the additional focusing for things that are up close. Once things start getting close to you, it takes extra bending of the light to focus them, and that's what the lens is for. You don't need it when you're looking at things more than like 20 feet away. Ciliary body includes the ciliary muscle, which pulls on the suspensory ligaments and changes the shape of the lens, okay? Iris is that colored structure. It consists of muscles to change the size of the pupil, all right? And the retina has the photoreceptors. They detect the light. So, features of the cornea and the choroid. Cornea continuous with the sclera. All right, it's all the same stuff like I said before. Essentially the same stuff, just arranged and differently to either let light through or not. A lot of pain receptors, as I just said. My son, who got scratched on his cornea once in a match, oh my God, he actually stayed home from work the next day. He actually stayed in bed. The pain was it was like, you couldn't believe it. Finally went to the doctor, got in to see an ophthalmologist, and she put a drop of, a local anesthetic, lidocaine, like on his cornea, and he said it was just like, Pain immediately gone. I guess you can't do that very often though, because it'll actually destroy the cornea. I know. My friend, the ophthalmologist, said that. You got to be careful with that. It's avascular, outside the reach of the immune system. All right, that's why they can do corneal transplants without fear of rejection. All right, there you go. Choroid, rich with blood vessels, supplies nutrients to the retina, produces the red eye in flash photographs. So, again, the pupil, lets the light through, and then it lights up all those blood vessels back there. A lot of nocturnal animals have a reflective layer called the tapetum lucidum. And that makes sense because it amplifies light. It's kind of like the big telescopes, the reflecting telescopes. They amplify the light. So you'll see that. Produces that eye shine. You see that in like cats at night. Look at their eyes glow. They have the tapetum lucidum. That lights up the inside of their eyeball. That's why they're good at seeing at night. Cats have really good night vision. You'll see that, I know, like down in the rainforests of Central America. It was great when there's so many different species of things down there, and we would do night hikes. And the great thing is, with your flashlight, you just shine it out, and you see the eye shine out there. It's awesome. See the big spiders? You could see all 8 of their eyes shining back at you. Really cool. So yeah, a lot of nocturnal animals have that. So some muscles of the iris. The constrictor pupillae are circular muscles innervated by the parasympathetic fibers of cranial nerve 3. Remember the ciliary ganglion. We saw that when we looked at the autonomic nervous system. Then there are the dilator pupillae muscles, which are radial muscles innervated by sympathetic fibers through the superior cervical ganglion. So look at that illustration on the left. See on the far left, those are circular muscles. They kind of, it's like the lenses of cameras can do that, where they close down in a circular fashion to limit the light. Whereas the on the right-hand side of that illustration, notice that the radial muscles are like those window blinds, where you pull on the cord and it raises the blind up and down. That's what the dilator muscles are like. So at any given moment in time, you have some mix of sympathetic and parasympathetic signals going to your eye, and that's what determines your pupil dilation. So once again, problems with dilating the pupil or constricting the pupil are possible indications of cranial nerve involvement or autonomic nervous system involvement, and other things as well. Physical injury to the eye can do that. Pupil size varies with lots of things, levels of light. So bright light, we constrict down. Low light, we open them up. Emotions and interests. That's how they say, if you're trying to figure out, you're dating somebody, you're trying to figure out, whether or not they're really interested in you or not, dilated pupils normally are a sign of interest. Don't go by that. Listen, if you get shut down on your first date, don't blame me, all right? It's not my fault. I'm just saying there's some research that indicates that kind of stuff. Head trauma and stroke. This can be a classic sign of intracranial bleeding and stuff like that. So you always check people's pupils. Notice how they do that. In a lot of exams, you always check the pupils. Pupils can give a lot of information about what's going on. Eye injury, of course, to the eye itself. Drugs, all right? Some of those various drugs, the adrenergic agonists and anticholinergics dilate the pupils. So people on cocaine and methamphetamine have big, wide open pupils. On the other hand, opioids, antihistamines, and sedatives constrict the pupils. So people on Xanax and heroin and Percocet and stuff like that have little pinpoint pupils. That's another reason they check the eyes. Anything out of the ordinary is possible indication of drugs. Anisocoria, condition in which one pupil is larger than the other, that's kind of a cool thing. It occurs normally in some people, but can also indicate trauma or infection. So there you see over in the bottom left some anisocoria, all right? See, one pupil dilated, the other one constricted. Again, it's natural in some people, but it can also indicate injury, like, again, intracranial bleeding and stuff like that. If somebody doesn't normally have anisocoria, and after head trauma they do, it's time to look more deeply into that, figure out what's going on. And what determines eye color? Well, each eye has a different mixture of ink loaded from the ophthalmic cartridges, just like your printer, your color printers. All right, it's the same thing. No, that's ridiculous. Of course, that's not the way it is. Common eye colors include brown, hazel, blue, green, gray. Depends on the amount of melanin, scattering of light in the iris. Determined by multiple genes, not a single gene determines eye color. Heterochromia is a condition in which the two irises are different colors. And it's common in some animals, including dogs and cats. You may have seen that before. Cats and dogs, different colored eyes. And the lower left, it's one of those heartwarming stories. Some little boy who had heterochromia got made fun of at school or something, and so, I don't know, there was a GoFundMe or I don't know, and they got him a cat that had heterochromia, and I guess it made him feel better. I don't know. Little kids. You shouldn't make fun of little kids. Little kids are so cruel to each other. We can all be different. It's okay. Let's just accept it, okay? And by the way, just those of you who are still in the dating market, I just want to warn you, women with green eyes have no souls. It's been documented over and over again, all right? So, no green eyes, okay? Stay away from those guys. That's just a joke. Just a joke. So the cavities, anterior cavity, anterior to the lens, filled with the aqueous humor produced by the ciliary body, continuously drained by the scleral venous sinus, the canal of Schlemm, replaced about every 90 minutes. So you recycle this regularly. And then there are two chambers. In between the cornea and the iris is the anterior chamber. Between the iris and the lens is the posterior chamber. Okay, but they're all filled with aqueous humor. The posterior cavity, which is behind the lens, has the vitreous chamber filled with the jelly-like vitreous body or vitreous humor. Okay. And interesting thing, well, that's formed once during embryonic development. So unlike the aqueous humor, it's not recycled every 90 minutes. You get it once only. And one of the cool things that happens is as you get older, cells die in your body. That happens constantly. You lose hair every day. Neurons die every day. That's normal. But what happens is the cells in the inside of your eyeball basically got no place to go. So they eventually just detach, and then they float around inside the vitreous humor. And you get, as you get older, you'll notice that there are these little gray spots in your field of vision. You can't always see them. Most of the time you don't, in fact. But under the right lighting, like if you look at, a blank white wall or something, you can see these little spots, and they call them floaters. And the interesting thing is, if you try to look at one, it will move away from you when you do that. I think there's an episode of Family Guy where he does that. But it's kind of funny. They generally don't cause any trouble. I'm 70 years old. I got bunches of them. I've given mine names, I've got Hector and, Alma, and, all my floaters have names. So they're common. They're usually not a big deal. And there you go. There's a different kind of floater. And there's yet a different kind of floater. Okay? All right, so glaucoma and cataracts, just a little bit of, a little patho-fizz here, just for the fun of it. So glaucoma, drainage of aqueous humor through the scleral venous sinus is blocked. Increases intraocular pressure, which is dangerous. That can put pressure on your retina, and you start to lose photoreceptors and stuff, and it can result in blindness, all right? So this is serious stuff. That's why when you go to the doctor, they have that thing like there on the middle on the right. You put your chin on that thing, and they say, I put your chin here, and you go, okay. And then a moment later, there's this burst of air right into your eye, and you go, damn, that was rude. Why did you do that to me? What they're doing is they're looking at the amount of deflection of the surface of your eye. There is a normal amount that your eye should deflect. If it doesn't deflect enough, that means maybe a sign that there's too much pressure inside, and so that's a potential warning sign of glaucoma. See, so even though they're rude, they're trying to help you out. Cataracts, this is a clouding of the lens, and it just happens as you get older. Your lens starts to cloud over. There's all kinds of gunk, like I said, cells are dying inside of your eye, and you just get crud all over your lens. Typically age-related due to thickening and hardening of the lens. Also because a consequence of diabetes mellitus, for example. So exacerbated by smoking, intense exposure to sunlight. And what do? That's my hiking buddy. She does a lot of cataract surgeries. They just go in and take your lens out and stick a plastic one in there. And by golly, you're good to go, all right? Back in the old days, my grandmother had cataracts, and they took them out, but they didn't have artificial lenses. That was before they had plastic. So they just took it out. What she had to do then, notice what's the lens for? It's for focusing up close. So my grandma had these glasses that, oh my God, they're like Coke bottle glasses, just thick as all hell. And that's what you used to have if you had cataracts and got your lens removed. Nowadays, of course, they can stick the plastic ones in there. And there you see on the left, dogs, the old dogs. Yeah, the eyes cloud over. Those are cataracts. So there you go, the scleral venous sinus up there. Okay, that's glaucoma. All right, which are the 5 basic tastes? Sweet, spicy, sour, meaty, salty, nutty, cheesy, smoky, fishy, moldy, bitter, hot, nasty, skanky, umami. Take a moment. Can you recognize the 5 basic tastes? I hope you can. I would expect you to on a quiz or an exam. Yeah, sweet, sour, salty, bitter, and umami. Hot, nasty, skanky, umami. Hey, what's your mom like? My mom, hot, nasty, and skanky. Whoa, like to meet your mom.